Some important parallels and meridians. Some lines of latitude and longitude have great significance in geographical studies. The parallel or latitude of 0 degrees is called the equator. Those of 23° north and south are known as the tropics of Cancer and Capricorn respectively, and the 66.5° north and south are known as the Arctic and Antarctic circles respectively. The equator not only divides the Earth into two hemispheres, the northern and the southern, but it is also the line of reference for all latitudes. The two tropics, as stated earlier, mark the limits of the zone in which the sun rays can be vertical at one time or the other. In fact, all places in the zone except for the two tropics experience vertical rays and of the sun twice a year. The sun is exactly overhead on the tropics only once a year. Tropic of Cancer at the time of summer solstice and the Tropic of Capricorn at the time of winter solstice. The Arctic and Antarctic circles enclose the polar zones where one can experience a continuous day or night for more than 24 hours, and outside these polar zones the day or night can never be as long as 24 hours or more. Among the longitudes, the 0 degree or the meridian of Greenwich is known as the prime meridian, and like equator in case of latitudes, it is the reference line for measuring longitude of various places. The plane of prime meridian also divides the earth into two hemispheres, the eastern and the western hemispheres. Area extending to its east up to 180° east is called eastern hemisphere, while the extending to its west up to 180° west is called western hemisphere. The line just opposite the prime meridian on the globe, the 180° longitude, is called the international date line. It passes through central Pacific and it is not a straight line as it veers to avoid passing through a major landmass of or a single group of islands. The international date line is the basis of keeping date, and the date changes as one crosses this line. The date in the eastern hemisphere is ahead of that in the western hemisphere. Therefore, as one crosses this line, one loses or gains a day depending upon whether the international date line is crossed from west to east or vice versa. Great circles and small circles. A great circle is a circle on the surface of the earth, the plane of which passes through the center of the earth. It divides the earth into two equal parts or hemispheres. A great circle is the largest circle that can be drawn on the globe. Conversely, a circle on the surface of the earth, the plane of which does not pass through the center of the earth and thus divides the earth into two unequal parts, is called a small circle. Among the parallels of latitude, only the equator is a great circle, and all other parallels are small circles. However, among the meridians of the longitude, all are great circles. However, a great circle need not follow a particular latitude or longitude. This possible number is infinite, and an arc of a great circle on the surface of the earth marks the shortest distance between two points on the earth. The navigators follow great circles routes to minimize the distance of their journeys. Motions of the earth and their effects. The earth has two motions, namely daily rotation and annual revolution. Rotation is the spinning movement of the earth on its axis, and the earth completes one rotation with respect to the sun. So that a given meridian passes in front of the sun for the second time in about 24 hours. This motion of the earth is called its daily motion. Due to this movement of the earth, each place on the surface of the earth in front of the sun and goes away from it in 24 hours. This movement thus causes the occurrence of day and night. Besides rotating on its axis, the earth also revolves around the sun and completes one revolution in about 365.25 days. The movement of the Earth is called its annual motion too. While the daily rotation of the Earth causes day and night, the annual revolution is responsible for the change of seasons. The path of Earth around the Sun orbit is elliptical, and consequently the distance between the Earth and the Sun keeps changing. It is minimum 1 crore 147 crore kilometer around January 3 when the Earth is said to be in perihelion and is maximum 152 million kilometer around July 4 when the Earth is said to be in aphelion. Due to the changing distance between the Earth and the Sun, the Earth as a whole receives more energy from the Sun during January than during July. Inclination of the Earth's axis and its effects. The Earth's axis of rotation, the polar axis, is not vertical but inclined, and it makes an angle of 66.5 degrees with the plane of the ecliptic. The plane of orbit of the Earth around the Sun and is tilted 23 degrees from a line perpendicular to the plane of ecliptic. The plane of ecliptic is imagined to be horizontal and to pass through the center of the globe as a result of the inclination of the axis of the Earth and its orbit around the Sun. The point or the line on the surface of the Earth at which the sun rays are vertical keeps changing from time to time. Hence, the amount of energy received at a particular place on the Earth's surface varies from time to time. This causes change of season. When the angle of incidence of sun rays at a place is vertical or nearly vertical, more energy reaches the Earth's surface and the place concerned experiences summer season. On the other hand, when the sun rays at the place are slanting, it receives lesser energy from the sun and experiences winter. Thus, the change of season on the Earth occurs due to the combined effect of the revolution of the Earth around the sun and the inclination of its axis. Had the axis of the Earth been perfectly perpendicular to the plane of ecliptic, the sun rays would have been vertical over the equator all the year round, and the amount of energy received at any place would have remained constant throughout the year. Hence, no change of season. Also, in that situation, the days and nights all over the earth would have been exactly equal throughout the year, as it happens at that time of equinoxes. Due to the inclination of its axis, the Earth attains for critical position in respect of the Sun during its revolution around the Sun. These are the equinoxes and the solstices. On June 21, the Earth is so located in its orbit that the north polar end of its axis leans at maximum angle of 23.5 degrees towards the Sun. The Tropic of Cancer receives the vertical rays of the Sun, and this condition is known as summer solstice, the longest day in the northern hemisphere. At this time, the North Pole experiences a continuous day, and the South Pole has a continuous night. At a given time, the light from the sun will be covering only half of the globe, and when the sun rays are vertical over the Tropic of Cancer, only the area to the north of the Antarctic Circle in the southern hemisphere will be illuminated, and the sun rays will not reach the south pole. On December 22, the earth is in equivalent but opposite position in its orbit. The tropic of Capricorn receives the vertical rays of the sun, and this condition is the winter solstice, the longest day in the southern hemisphere. At this time, the North Pole experiences a continuous night and the South Pole has the continuous day. Since the inclination of the Earth's axis is on 23.5 degrees from the vertical, the sun rays can be vertical only up to the two tropics. Beyond the equator, hence the tropics mark the pole word limits of the zone in which the sun rays can be vertical at any time in the year. Midway between the two solstices occur the equinoxes when the Earth's axis makes a 90-degree angle with the line drawn to the sun. The equator receives the vertical rays of the sun, and day and night are all equal all over the world. And the vernal or the spring equinox occurs on March 21 and the autumnal equinox on September 23. At the time of the winter solstice, the sun is not visible to a person on the North Pole, and during the summer solstice, the sun is not visible to a person on the South Pole. When the sun rays are vertical in the northern hemisphere in the month of June, they are highly slanting in the southern hemisphere. Likewise, when the sun is vertical over the Tropic of Cancer in the southern hemisphere, the sun rays are slanting in the northern hemisphere. The seasons in the two hemispheres are therefore reverse of each other. When it is summer in the northern hemisphere, it is winter in the southern. When it is summer in the northern hemisphere, it is winter in the southern, and vice versa. At the time of the summer solstice, the North Pole has continuous day, while the South Pole has a continuous night. An exact but opposite position is reached at the time of the winter solstice, when there is continuous day at the South Pole and a continuous night at the North Pole. The longer than 24-hour they are experienced only in the Arctic and Antarctic circles. The maximum length of the day as well as of the night is observed at the two poles. At the equator, the days and nights are exactly equal all the year round, but elsewhere it is possible only at the time of equinoxes.